All right, so here's our app up and running. What we did was we created name, email, and food. We had a database we created last time around that we were going to save information to. We have like one line of information, and then what we did was we had view database using table and view database using picker, and these were labels. So these were labels, interestingly enough, and we created these touch events. So every view controller has a touch event where all you do is touch the screen, and then based on the XY location of where you touched, you can determine whether you want to do something or not. So kind of like a secondary event handler that you can have at your disposal instead of just attaching an event handler to a particular item like a button. You can do it this way as well. So we clicked on view database using table. We have an empty table here. Kind of tricky to see, but if I swipe up and down, you kind of see the grid marks there. And so we got the back button working. Picker, we have an empty picker, right? It's just like the one line there, which we're going to learn how to do soon. So at this point, we had built out the GUI, and we built out the navigation for the GUI using touch events. And so now what we're going to focus on is the database interaction. So what we did last time around was we had started into database interaction, and we started inside did finish launching with options. But to go back to the header file for a sec, we had created a couple of strings, database name and database path, and then we created an array called people. And so the database name was we're just going to hard code our file name, which was mydatabase.db, which we have here in the project. Database path. Now this is the path on the device to where we're going to keep the file. So for example, on our Windows or Macs, we would have like a My Documents folder. So it seems fitting to just throw the database into that type of a folder, but on the iPhone or iPad itself. And so the iPhone and iPad do have file systems, like how we see on our regular computers, but they're not really so open about it. So when we save files to pictures or videos or something, they're actually being stored in specific places. And so what we want to do is we want to put our database file in a specific place and remember that place. And we want to let the phone determine that for us. So going to the M file, we started off and did finish launching with options by, well, initializing our people array to be empty, and then having our database name be mydatabase.db, and then going ahead and determining where our My Documents folder was going to be. So we used NS search path for directories and domains, and we want to look for the NS Documents directory. So there's the document directory, there's a documentation directory. You have to be very careful. The document directory is what we want, which is really our My Documents folder. And the documentation directory is really the help files, which we don't really have access to. We really just wanted it from a user's perspective, which was the second argument here. We don't want to be super user. We don't want to be anything more advanced. We just want to be a regular user that could save something to our My Documents folder, essentially. That's what's going on here. And so we built out a path saying, like, for example, like my documents / mydatabase.db, which is what we built out here. Now, at this point, we had stopped, and we had paused our app at this point. But our next step is to actually go in and check to see if the file already exists. See, here's the thing. So when we first install the app onto our phone, and when we first build it in Xcode, we have these files, mydatabase.db. We might have some images. We'll have our code. It'll all get bundled up into one app file, which I believe I can show you under products here. Yeah, so you see here database intro.app. This is the final product. This is the final product. It's just one big binary that bundles everything into it. Think of it like a zip file almost, where you zip everything together, right? And so we would upload this to Apple servers, and it would eventually end up in the App Store. And so then we would download it from the App Store, that particular app file in the background, onto our device. And so what happens is that inside of it, we have the mydatabase.db file. It's not any good to us inside the app file. It has to actually be placed in a place where we can access it. So what we have to do now is, in the first time we run this file, is determine if we already have this file. And so the best way to do it is to check to see if the file exists, right? If it doesn't, copy it over. So basically pull it out of the app file, copy it into our My Documents folder. And so that's the next method is all about. This is what we're going to do here, is to check to see if this file already exists. If it doesn't, copy it or basically pull it out of our downloaded file, our downloaded app file, and place it into some place on the file system we can work with. So essentially we'll have two copies of this file, but one will be built into our app file, one will be on our file system, and that's the one we'll work with. So we're going to create a new method, and it'll be a void return type, and we'll call it check and create database. Now we're in appdelegate.m when we're doing this. So you're going to find that the code is going to get a bit more trickier in these next three methods that we're going to make for the app delegate. This method is purely Objective-C, but the next two methods will have a lot of C code mixed in with it, which will get kind of ugly. But we'll start off one step at a time. First thing we're going to do is create a variable, bool return type, call it success. And all we want to do is check to see if the file already exists, meaning that this is probably the second, third, fourth, or fifth time we're running this app. So we've already copied it into the file system and we're already using it. So what we're going to do is declare an object called NSFileManager. And we'll just call it FileManager is equal to NSFileManager default manager. Right? So this object NSFileManager, its purpose is to integrate with the file system, interact with the file system, and determine if there's files there, or operate on the file system itself. So maybe copy files, load files, and so on. So that's what the NSFileManager's purpose is. So now that we have the file manager here, let's determine if the file already exists. So we already have mydatabase.db in our my documents folder. That's what we're going to determine, right? So what we're going to do is we're going to say success equals file manager, file exists at path, and we'll pass in self.database path because we already created it inside did finish launching. Database path has been we've set it up that this is the path we want, so it's already there. So let's take advantage of it and let's just use it. All right, so this will return yes or no. If this is our first time loading the app, this is our very first time, it's a fresh install, it means that we don't have this database file in our documents folder. So it's going to return no. All right, if it's a yes, meaning it already exists, then we're done. We've just verified that the file already exists. So we'll check for that status. We'll say if success return. Right? So we'll get out of the method, meaning that if it already exists, it's our second, third, fourth, fifth, and so on time running this app. Otherwise, it's our first time running the app, so we actually have to take this file and basically copy it into our file system in the location we want it to be. So first thing is we have to figure out where this file is inside our app file. So again, think of it like a zip file where we have all of our files. When you open up WinZip or 7-zip or whatever zip program you use or WinRAR to view the files inside a zip file, you'll see that it's all listed out. Like it's almost like there's a mini file system inside of it as well, right? And so we want to determine where exactly our database file is inside the app file, thinking along those lines of a zip file. So we're gonna create an NS string. So NS string, call it database path from app. I know it's a bit long. Is equal to a triple bracket here, NS bundle. So here we go, we're using NS bundle here. Main bundle, which refers to our app file. Resource path, which says we basically access the quote-unquote file system inside the app file to determine where the file is. String by appending path component. And we'll pass in self.database name. So basically what we're saying here is figure out exactly where the database file is, mydatabase.db, inside the app file, create a path for me inside of it. So it could be like slash my, database intro.app slash my documents slash database or mydatabase.db or something like that along the lines, right? So we'll basically create a path for me that I can use. I can figure out exactly where inside the app file my database.db is. And so once we figure out exactly where the file is inside the APP file, we can take it from the APP file, copy it, and paste it into our file system, or basically inside our database. Oh, sorry, inside our documents folder. So we're going to say File Manager, copy item at path. And so we're going to say database path from app to self.database path. Error is nil. We won't worry about any error messages this time around, or any error handling. This is assuming that the file already exists inside our database, or inside our APP file. All right, so we have this method. This method's complete now. Basically, we are checking to see if the file exists already. If it doesn't, copy it into the location we want. Otherwise, just return. That's really what this method is doing. So let's actually take this, copy it into our H file, so we have access to it in the outside world. So copy the function prototype, paste it into the header file. But we still have one more thing to do with this method. So we're going to jump back to the appdelegate.m file. We got to call it somewhere. So we created this method, but we haven't called it yet. So let's call it inside did finish launching. We want this called right when we start up the app, just to determine whether we have the file existing. So right here, just before the return yes, inside did finish launching, we're going to call this method. So we're going to say self check and create database. All right, so the next step now is to retrieve the data from the database. At this point, we've figured out where the database file is. We place it in the file system. We know exactly where it is and how to access it. Now let's access it. Let's retrieve the data, and let's paste it into our table so we can view it and verify that it's there. So that's going to be our first step. So we're going to create a new method again inside appdelegate, and this one is going to be for retrieving data from the database. So I'll do it up here. Create another one. This will be a void return type. Now this method, the void return type, we'll call it read data from database. This could be a bool return type, but for time's sake, we're going to leave it as a void. We can do some error checking in here to verify that, hey, this database file isn't corrupted, or that even though we copy the file in, that there's something off about the file, right? We could do some error checking, but we're going to let it be. We'll just keep it as a void return type. So our purpose here is to retrieve data from the database. We need to use SQLite here. And last time around, as you can see, we brought in the libsqlite 3 libraries. So we have it here ready to go. So all we have to do now is include the header file for SQLite. So we're just going to jump back to the top of the file for a second, and we'll come back. And we're going to import another header file. We're going to say import. This will have the angle brackets, SQLite 3.h. Right? So we are importing SQLite 3.h. This file will have all the functions we need for working with the SQLite database. Now, notice it's in angle brackets, meaning it is a system file essentially. It is not a local file like appdelegate is, or the other header file are that we use. So what we're going to do now is jump back to the method and actually use it. So back to read data from database. And our first step inside read data from database is we're going to empty out the people array. Now, first time around, this isn't really a big deal, running this method the first time, because our people array should be empty. But if we were to read this data from database again over and over again, we might end up appending to it. So we want to make sure that we have an empty fresh array every time. So we're going to say self.people, remove all objects. That's the nice about mutable arrays, is that you have a lot of flexibility here. And then from here, we're going to declare an SQLite3. I don't want to say object, because in C there really aren't any objects, but we'll use it. But we're going to use the term object very loosely here. So SQLite3 database. And yes, this is a pointer from C. Now we're going to be using some pointers here. So I can almost see the pain happening really soon. All right, so this is going to be a pointer to our database object on the file system. That's its purpose here. It's going to be so that we can have access to the database file. It's a pointer here. Now what we're going to do is we're going to write some C code to first off open the database. So our first step is to open the database. But we're going to embed them inside if statements to reduce the coding. So we're going to say if SQLite 3 underscore open, and we're going to pass in, well, we want to pass in the database file itself, right? The path to it. So we want to pass in database path. The problem here is that this is a C function. So C does not understand NSString. NSString is part of Objective-C, right? So we have to convert the NSString to a C string, which is really a UTF-8 string. Right? So the function the method UTF-8 string will do that for us. So we're going to say if SQLite3 open, we're going to say first argument is self.database path UTF-8 string. Right? So that will convert it to a char star essentially, or a character array for C that C can understand. Second argument is our database object we just created a line above. So we're going to say ampersand database. Notice we use the ampersand here. We're passing the address of the database object. So pointer passing, call by reference, all those wonderful things that C has, is coming back to haunt us now. Now this function will return a code that is called SQLite underscore OK if it is good. Like assuming everything's okay, it's able to open the file, no problem at all. It'll return SQLite OK. Whenever this if statement fails, it basically means that the other methods above that we created for determining the database path and for copying the file into database path, those failed. Meaning that we didn't copy the file properly. And more often than not, I found that it was really that we were trying to copy to our documentation directory than anywhere else. So always double check that. All right, so assuming this passes, let's create our query. So our query will be in a C character array. So we're going to say char star SQL statement is equal to, and remember this is a C string, not an NS string. So we're going to say no, we're not going to put an @ symbol. We'll just say double quotes select star from entries. Remember, entries is the name of our table, and that's our typical query. So we have our query here. The query itself has a support object. Any transaction we do with this database right now has a support object. And so that support object is of type SQLite 3 underscore STMT, short for statement. So SQLite 3 statement, we'll just call it compiled statement. So this object, and again I use the term object loosely because it's a C struct essentially, its purpose is to manage the transaction itself. So our select star from entries, it's going to be the manager for this. So it'll retrieve the data back. So we're doing a query, we're doing a select here, so it'll retrieve back the data. We'll have to go into this object and pull out the data in a moment. Or if we're doing an insert, which we will do later, we'll have to pass the data in to this object, and then it'll send it off to the database. So it's kind of like the manager. It manages a transaction. So we have to prepare this object. We have to instantiate, well, again, not instantiate, but allocate memory for it and so on. So we're going to put this inside another if statement. So we'll say if SQLite3 underscore prepare. We're going to use v2, prepare v2. We'll pass in the database as our first argument. SQL statement is our second argument. Our next argument will be number of bytes. We don't know how many bytes we want to retrieve from or pass to in this case, so we'll just put -1. -1 just says we don't know. All right. The next argument is the compiled statement object. But again, we're saying ampersand compiled statement. Because again, we're passing the memory address of the compiled statement. And the last argument is null. Not nil, but null, because this is a C object or C function. It will return SQLite underscore OK again if it's run properly. So we'll say if it's equal to SQLite underscore OK. So this allocates memory for the object. It basically copies SQL statement, the variable into SQLite3 statement. It does all the background work that we need to get this transaction ready to go. Now, because this is a select query, we're just basically going to run this at this point, but we're going to run it one row at a time. And the way to do that is to put it inside a while loop and run this over and over again. So we're going to say while SQLite3 underscore step for compiled statement equals SQLite underscore row. So this query will get run over and over and over again, row by row by row, until there's no more rows to retrieve. That's really its purpose here. At this point, what we can do is we can pull out our data. We now have a row of data to process here. So we'll do this in 2 steps. What we're going to do is we're going to pull out a string. So we have, think back to our table here. Our first column was the ID. It was an int or a number. Our second column was name. It was text. Third column was email. It was text again. And fourth column was food, text again. For this exercise, we're going to ignore the ID, but you may want to pull out the ID in the future for your applications, because if you want to do an update and delete, it's most useful there, right? For us, we're going to leave it. We're just going to stick to name, email, and food. And so what we want to do is we want to pull out the name first of all. So we'll just say char star n for name is equal to. Now if I type in SQLite 3 underscore column, there's a lot of column functions here. A lot of column functions. And there's blob, bytes, count, double, int. If you had an int, you had a double, you could retrieve it based on those types. We're looking for text because our column type is text. So underscore text. I'm going to use text, not text 16. 16 for 16-bit. And what's happening here is that it's going to retrieve a column formatted as text, return it as a character array. Now, my first argument is compiled statement. My second argument is the column number. So column 0 was my ID. Column 1 is my name. So I'm going to put column 1, or just 1, for the column number. Now, this, I'm going to do this again for the other 3, or the other 2 columns. So I'm just going to copy and paste because it's, well, it's a lot to type. So just paste it 2 more times. And so the second column will be E for email. And F for food. And E will be column 2 and column 3 here. So I now have name, email, and food, but here's the problem. These are in C strings, but now I want to jump back to Objective-C for NS string type. So what I want to do is I'll be able to convert these from character arrays in C into NS strings. So there is a method to do so inside NS string. So we'll say NS string, call it name, is equal to NS string, string with UTF-8 string, passing in, we'll pass in N. The next thing, we'll do the same thing for email and food. So we'll say NS string, email is equal to NS string, string with UTF-8 string, and pass in E. And then NS string, food is equal to NS string, string with UTF-8 string, F for food. So we have name, email, and food. But we want to add this to our people array. Our people array, its purpose was to basically be an array of data objects. Last time around we created data.h and .m. So what we want to do now is be able to instantiate a data object, save this information there, and add it to our people array. So to do that, we have to import data.h. So what we're going to do is we're going to jump back to the top of the file, import data.h. Import data.h. And then we can jump back to the method and finish it off. So we'll say data. I'm just going to call it data with lowercase d is equal to data alloc init with data. So the same constructor we created last time around with name, email, and food, we're just going to use that. And we'll just pass in name, email, food. And so now we're going to add this data object to our people array. So we're going to say self.people add object data. All right, and so that's it. That's one row. That's one row of data from the database. Right? So now we're done. We're basically done with this method, but we just have some cleanup to do. So at this point, we've opened a database connection. We prepared our compiled statement object, or basically our manager for managing the transaction. We've gone in, we've done the transaction, we've pulled out the data row by row by row. We've inserted into our people array. We're done. We just have to clean up things. So with automatic reference counting, things were done for us. Right? So any object we instantiated was freed on its own or released on its own. We didn't have to worry about it. But here, because this is C code, we have to do our own freeze. We have to free stuff up. But that is done for us inside functions that we call. So outside of the while, outside of the if, let me go up here. So outside of this if, after this if, we have to basically free up compiled statement, because this if line actually allocates memory for compiled statement, does all the work it needs to do. So just outside of the second curly bracket, closing curly bracket, we're going to say SQLite3 underscore finalize, passing in compiled statement. This function, it basically just frees up memory. It cleans out all of the memory allocated, closes anything up, any other background work that needs to be done, it'll take care of it. That'll basically remove itself from the system and free up the memory for somebody else to occupy. One last thing we have to do just before the closing curly of this method, we have to close our connection to the database. So we're going to say SQLite3 underscore close, passing in database. And so now our our read data from database method is done. At this point, we have enough to retrieve data from the database. The only thing left now is to actually go in to the table and or the page with the table on it, and actually implement the methods we need to retrieve data from the database. All right, so we have this method called read data from database. What we're going to do is, first off, we're going to take this method call and we're going to put in our header file. So we're going to go to app.delegate.h, put it inside our header file so that we can call it outside. All right. The other most important thing we have to do is we have to call this method. So just like we did check and create database, we want to call it at the same point we called this, check and create database, inside did finish launching with options. So we're going to jump back to the M file and jump back to did finish launching. And after check and create database, we're going to call self read data from database. And so now our did finish launching with options method is complete. What we want to do here now is actually retrieve the data from the database and display it in our table. So moving over to table view controller.h, we're going to start by defining everything we need to define there. In this case, we want to bring in the two delegates. So we're going to say UI table view data source and UI table view delegate. Now, other than that, I really don't need any other variables, but I think we're going to simplify some of our code. In our past apps, we've been calling app delegate over and over and over and over again, and it was kind of a nuisance after a while. So why don't we just define app delegate here? So let's say app delegate and call it main delegate. And of course, we have to bring in the header file for it too. All right, and then we'll do the property declaration for it too. Accidentally hit build by accident, or command B. All right. So we have here our app delegate declaration. That's about it. That's all we're going to put inside this. Now, in the last app, when we were dealing with tables, last two apps, when we were dealing with tables, we created some variables here, like some arrays to work with and stuff, but we don't need to here because we've already created our people array in our app delegate, so we're just going to retrieve the data from the people array. Okay, so now let's move over to our M file for table view controller. And let's start by synthesizing app delegate. There. So let's start with view did load. And what we're going to do here is basically get the app delegate set up here. So we'll say main delegate is equal to app delegate star UI application shared application delegate. And what this does is I don't have to call this line anymore. It's already done inside. It's already done inside view did load. So now I just have to refer to main delegate whenever I want. That's all. And let's go ahead and call main delegate read data from database just to be sure that we get the latest. The reason we're doing this is because once we get into inserting data into the database, we would do that on the home page. And then maybe our first instinct at that point is to go to the table page or the picker page and verify the data was inserted. So we need a way to refresh, get the latest and greatest copy from the table. So we're going to do that here. We're going to retrieve data from the database here as well, just to be sure that we're getting the latest and greatest copy from the table. All right? So that's the purpose of doing that right now. So now we can go ahead and create our table methods. So I'm going to do a little bit of a pound pragma here, mark, and say view methods for this. And then do another pound pragma, mark, and say table methods. And so just to recap, we have our special methods that we use for getting the table up and running. So let's start by defining how many rows there are in the table. So we're going to say ns integer. Start by typing the word table. Look for number of rows in section. We'll just return the length of the people array. So we'll say return main delegate dot people count. See, isn't that nice? We don't have to call up the app delegate again. It's done for us once in view did load. So at this point, we just call up main delegate as often as we want. So really convenient. The next step is to define how thick each cell is going to be. We'll keep it simple this time around. We'll just define 60 pixels. We're going to keep this to one device here. So we'll say CG float, return type, type in table again. We're looking for height for row at index path, not estimated height for row at index path, but height for row at index path. So height for row at index path, return 60. And we'll get rid of the warning here by implementing what to do with each cell. So it's a UI table view cell. Start typing in table. We're looking for a cell for row at index path. Right now, our generic cell would be the default item to go to for this table, but we already created a customized cell in our last app. Why don't we just bring that into this project and just reuse it? Because it has like a primary label and secondary label. It had an image graphic location. We're going to leave that alone, but we'll still be able to take advantage of everything else related to that table cell. So why don't we bring it in? So we're going to do here is we're going to right click on special classes and say add files to database intro. And here's where you got to navigate back to that previous project you created and cite cell.h&m. We're going to bring those in and make sure that copy items if needed is checked. So I'm just going to navigate back to week 9. And look for there's citecell.m. And here's citecell.h, just holding down command to multi-select. And bring them in. Remember, check copy items if needed is checked. We'll hit add. And notice that we now have citecell.m, citecell.h. So we now have our cite cell. So why reinvent the wheel? Let's just use it. We won't bother with images this time around, but at least we can take advantage of the big and the primary and secondary label. Makes it nicer. So and the spacing is perfect because we're still using a 60 pixel high cell. So what we're going to do is just having a look here. Nothing really other thing to change. In fact, it's got our convenient iPad configuration inside of it too. So let's go back to table view controller.m. Now that we have the cite cell, we'll go to the top of the file. We've got to import citecell.h first of all. So we can take advantage of it. And then we can go into self-road index path and actually implement our cell method. So first thing is we'll create a cell identifier string. So we'll say ns string, call it cell identifier. We'll just say cell here. Remember, we're using an @ symbol again now. We're back in the Objective-C world. First step is to check to see if cells already exist that are coming off the screen. They're leaving the screen. We can reformat them. We can repurpose them and put them back on the screen. That's our first check. So we're going to say cite cell. Let's call it cell. Is equal to cite cell star, and we'll say table view DQ reusable cell with identifier, and pass in cell identifier. Now, if we're still loading up this table for the first time, we're still instantiating cells, this will return nil to basically say, hey, you still got more cells you could possibly instantiate. So we'll say if the cell is nil, go ahead and instantiate it. So if cell equals nil, then we're going to say cell is equal to cite cell alloc init with style, which we created last time around in the last app. And we'll pass in UI table view cell style default and pass in our reuse identifier, so cell identifier. At this point, we have our cell. We can go ahead and populate the cell. So let's go ahead and do so. So let's retrieve the row number we're dealing with. So we'll say ns integer row equals index path dot row. And let's now what we want to do is we want to retrieve an item from the people array. But again, this array of people has an array of data objects here. So we got to jump back to the top of the file and bring in data.h. So we'll jump back up. We'll import data.h. We'll jump back to our method. So now we could say data d is equal to main delegate dot people object at index row. See, pretty convenient. We don't have to recall up the, or I don't want to say instantiate, but basically set up main delegate again. It's done for us. And we can go ahead and populate the primary and secondary label. So we'll say cell.primarylabel.text is equal to d.name. Cell.secondarylabel.text is equal to d. We'll put the email for the secondary label. We're almost there. We can actually run this and see and test out our code here. So we're going to say now is cell.accessory type is equal to UI table view cell style cell accessory. I'm going to use disclosure indicator and return cell. So at this point we've written a lot of code and we haven't run our app yet to make sure everything's up and running. The difficulty here is that we have no way of running anything up until now because we were retrieving from the database, doing a lot of behind the scenes work that we had no way of testing at all. And so now what we're going to do is we're going to put this into action and actually test this out. So at this point, I'm going to connect up everything in the table, data source and delegate, and then I'm going to run this app. So just jump to main storyboard, under the table view. If I click on the table view, connect data source and delegate to view controller. And just jump back to the code, then I'll run it. So there's our loading screen. Here is database intro. We'll view database using table. I have Jim Kirk, Darth Vader, and Yoda. I'll hit back and go back again. But if I go to my picker page, it's empty. So the next step is to get the picker up and running as well. But one other thing we want to do here under the table, right now we click on them, nothing happens. So we want to maybe get an event handler going to display the food here. Okay, so now the next part here is to get the event handler going for the table. So we'll create another method down here, void return type, type in table, and we want did select row at index path. So did select row at index path. And what we're going to do is we're going to get the alert box to pop up. So what we're going to do here is get the row number we're dealing with. So ns integer row is equal to index path dot row. We're going to retrieve the data object again for the particular row. So we'll say data, call it person is equal to main delegate dot people object at index row. Let's set the title to be the person's name and the message to be the food. Of course, you can dress up your alert box as you see fit. We'll just keep it simple for our application here. So we'll say ns string title is equal to person.name and then ns string MSG is equal to person.food. Now, the next step is to get our alert box going. So it's a 4-step process, as usual. And so what we're going to do is define a UI alert object. So we're going to say UI alert controller, call it alert, is equal to UI alert controller, alert controller with title. We'll pass in the title variable we just created, the MSG variable we just created, and the style will be UI alert controller style alert. So there's our alert controller. The next step is to define an action. So we're going to say UI alert action, call it the OK button, is equal to UI alert action, action with title. And so we'll say the title for this this button is OK. Style is UI alert action style default. No event handler, so we'll say nil. Because really we're just going to have an OK button that when you click on it will just make it go away. That's all we care about. The next step is to add the OK button to the alert. So we're going to say alert, add action, OK. And finally, let's make it happen, make it display. So we'll say self present view controller. So presenting alert, animated, yeah, let's make it animated. And completion handler, none, so nil. So we don't want any event, we don't want any code to execute upon hitting the OK button or upon finishing off this thing. And so now we have our final method for the table implemented, so we'll just run it and verify that it's up and running. And so now at this point, we've created the database, we've created the entire GUI, we've created touch events, so clicking on these labels, and we have our items in the table. So for example, if I click on Jim Kirk likes pizza. If I click on Darth Vader, well, we don't really know what Darth Vader can eat, so I just said mush for lack of a better food. And Yoda, well, a guy like that, maybe he eats bugs, for all we know. So essentially now we have alert boxes pop up that will tell us the food. At this point what we'll do is we'll stop this part of the app, and in the next part what we're going to do is we're going to finish off this app in the third and final part by getting these text boxes to work and to get the save button to work and get it to insert into the database. So we have to add one more method to AppDelegate to do an insert. And the next thing is we have to get the picker up and running so it can display those items as well as have an event handler to execute an alert box for when we select an item in the picker. But that'll be done in the next part, the third and final part of this app.